This presentation will have three different presenters. I'm from the Western Local Land Services in Western New South Wales, and I manage the Rangeland Rehabilitation Program. After me, Luke and Sarah Mashford will present. They're from Katalpa Station, where a lot of this work has occurred. And Susan Orgill is from New South Wales Department of Primary Industry, and Susan's done a lot of the research into ground cover and soil carbon. So this presentation is about increasing ground cover and soil carbon on a large scale using rangeland rehydration techniques. So we're talking about landscape scale rehydration, and how does that work in Western New South Wales? So the Western Local Land Services has a program called the Rangeland Rehabilitation Program, and we have a lot of experience in numerous techniques. These are things like water ponding, water spreading and contour furrowing. A lot of these were developed by the Soil Conservation Service. And we have a lot of expertise in laying out these broad scale projects over 100 or hundreds of hectares. In 2016, we teamed up with Hugh Pringle. Hugh Pringle runs Ecosystem Management Understanding. And this is a process whereby land managers strategically plan for rehabilitation works and they develop priority projects. It's also looking at landscapes as a drainage ecosystem. So looking at how water flows through the landscape and what it should be doing as it flows through the landscape. So by combining LLS and EMU, we are able to really achieve some really good landscape scale rehydration. So this example I'll give is from Katalpa Station. So here we've identified a degradation issue using the EMU techniques. It was a perched floodplain due to gully erosion or an expanded channel, so the water wasn't able to get out of that erosion gully. And we constructed a check bank across that erosion gully, which turned into a diversion bank, which turned into a water spreading bank. So a total of 1.3 kilometres of bank. And just follow the blue arrows and you'll see what the water does now. It goes out of that erosion gutter and spreads out onto the floodplain. And those horseshoe-shaped banks on the left-hand side of the photo, I'll talk about them later. They're water ponding banks. But as a result of that 1.3 kilometres of bank, we have 500 hectares that's flooded on only 25 mils of rain. So that's a really good result. And that dotted line represents that 1.3 kilometres of bank. So the next example, here we have a keyline area. Keyline is where the water flows change from a tributary flow to a distributary flow, where the water should be fanning out, spreading out. But in this situation, the water doesn't fan out or spread out. It's a erosion gully. 800 metres from the keyline to the exit point is a straight erosion gully. It doesn't spread out at all. So what we did, these black lines represent banks that we constructed. We constructed a series of banks which takes the water out of that erosion gutter and spreads it out onto the surrounding floodplain, and it meanders 2.4 kilometres now. Instead of 800 metres, it meanders 2.4 kilometres, creating another flow line, and it really soaks in as it's doing that. We also constructed a series of water ponds. These water ponds recreating ephemeral wetlands, and they're restoring degraded gilgai areas. So that's another example here where we've used multiple techniques and it re-establishes landscape processes, proper processes. Thank you.
Thanks, Paul. In 2012, my wife Sarah and I purchased Katalpa Station. It's approximately 123,000 acres and located 230 kilometres northeast of Broken Hill between Whitecliffs and Tibooburra. We are on two main rangeland types, that being the Downs country of the far west and Mitchell grass plains.
Average rainfall is 210 millimetres. In 2020 we had 190, and this year to date we've only received 60. Maybe the tap is turning off again, so this year our lambs were turned off as suckers to the feedlots. We are also in the process of reducing the number of our current flock of 3,000 Doonie Merino core breeder ewes. If the rain fails to eventuate this spring, we'll be utilising containment feeding infrastructure once more to protect our pastures. In the late 1800s, Katalpa was part of a larger holding called Katalpa Station. It encompassed 1.1 million acres, and the livestock were watered off of seasonal natural water holes in creeks, 4 artesian bores, and a limited number of earth dams. The government of the time recommended a carrying capacity of 1 sheep to every 7 acres. This equated to approximately 150,000 head on Katalpa. The block of land we now know as Katalpa had been periodically stocked at 15 to 20,000 sheep, with a mere 3 permanent watering points. In 1928, it was split from Katalpa. By comparison, now we run 3,000 ewes on that same block, with not only 3 but 19 watering points. There are a number of factors that have shaped Katalpa and much of the country in the Western Division into what they are now. Not only the heavy grazing pressures of late 1800s and early 1900s, but also Federation drought, rabbit plagues and the devastating 1914-1915 drought. Pastoralists concerned about the large-scale erosion and accelerating landscape dehydration have been well documented. When we first came to Katalpa, we knew we had a problem with erosion and dehydration, yet we had limited knowledge with how to approach it. Western Local Land Services Paul Theakston, we began the education that we needed. Our first project dealt with the associated problems leading into our house dam catchment. He used proven soil con methods and surveyed some 2,000 acres of gully head catchment. With local earth moving contractors, we commenced a battle plan and the address of loss of topsoil. In the Western Division, we have a large number of like-minded pastoralists with a variety of degradation issues. Paul Theakston, along with Russell Grant, managed to introduce a group of us to Dr. Hugh Pringle, who is the co-founder of Ecosystem Management Understanding. This group operate properties that were part of the original Katalpa lease and together are responsible for roughly 700,000 acres. We share not only boundary fences, but creek systems, drainage lines, landscape types, ideas and theories. Together with Paul and Hugh, we all then actively work to form a baseline ecologically understanding of both individual and the adjoining properties. This allowed us to understand the functions of the tin roof, downpipes and the rainwater tank as a system in its entirety. This process then identified key drainage issues and the tools plus the know-how of fixing them. Small grants were made available by Western Local Land Services, which resulted in a variety of initial projects being completed. They have shown really promising results post-rainfall. Due to our landscape type at Katalpa, we are using graders in our rehab efforts. All works are surveyed with the intention to reset the water drainage baseline heights. This helps to recreate the natural flow of water across the landscape using champagne banks, gully head check banks, bonds and spreader banks. The flow of angry water ripping through gullies is being interrupted now and diverted onto smaller gradients. As the energy is now gone, the gully's ability to strip topsoil is greatly reduced. In the treated areas, we are now seeing the catchment of native seeds, rehydration of ancient gill guys, and resurrection of habitat. Also seen is an increased healthy, sustainable grazing conditions. We are really excited for the future of our rangelands. Interest and uptake of regenerative works by more and more pastoralists is growing every year. So under Western Landcare, an alliance is formed with 22 family-run pastoral businesses responsible for roughly 3 million acres. We are called the Far West Rangeland Rehydration Alliance. Everyone has completed the EMU process and continue to do amazing projects to protect and enhance their ecosystems. Our purpose is to knowledge share, plan future works and also to make some noise in government departments for an increase in resources, such as more rangeland rehabilitation officers, small grants and the involvement of future experts. Despite the size and the scale of the erosion legacy we face, there are many landholders out here motivated to make a difference.
Involved pastoralists and their families are informally committed to benchmarking their progress through the Rangeland Rehydration programs. We want to be able to continue to raindrop manage in an economically sustainable and environmentally beneficial way. We are really pleased to have the involvement of the New South Wales DPI and Susan Orgill with her team. It is one thing to be able to see the benefits of our works, but to have some scientific data to back it up is now really exciting. So over to you, Suze, to see the evidence.
My name's Susan Orgill and I'm a soil carbon researcher with New South Wales Department of Primary Industries. Our R&D team were interested in the ground cover and soil carbon benefits of interventions designed to rehydrate rangeland soils. At Katalpa Station, we divided our sampling area into two zones, the ponded area and the runoff area. Now, these interventions had only been in place for a couple of years, so we're looking at the early stages of plant succession and changes in soil carbon stocks and flows. For the pastures work, we looked at ground cover, plant composition, plant biomass, and utilisation. Overwhelmingly, there was a significant increase in plant cover, litter cover, biomass production and species richness in the ponded areas when compared with the runoff areas. For example, there was over 4 tonnes per hectare of biomass in the ponded area compared with only 80 kilos per hectare in the runoff area. For the soils component, we used a hydraulic corer to collect intact soil cores to 30 centimetres. Soil samples were analysed for a range of chemical properties, including soil organic carbon, and physical properties, including bulk density, gravel percentage, and texture. If we just look at these two photos on the screen now, we can see the enormous transition in vegetation that's occurred in a very short period of time due to this management intervention. When we're talking about soil organic carbon stocks and flows, it's all about a balance. Organic matter supply through plant growth needs to be greater than organic matter loss through erosion and decomposition. Plant growth also prepares and protects the soil surface from erosion, increases infiltration, buffers against changes in soil temperature, and increases the energy flow of carbon through the soil through root exudation. One of the metrics that we looked at was the coarse organic matter fraction. Coarse organic matter is the organic matter that's greater than 2 millimetres in length. Typically this is discarded by labs, but we've found it to be a sensitive measure of carbon accumulation in rangeland soils. There was a significantly greater proportion of coarse organic matter in the ponded area compared to the runoff area. This is important because it indicates that there's a greater organic matter supply where the soil has been ponded and greater plant biomass compared with those runoff areas. We also looked at soil organic carbon stocks. To calculate soil organic carbon stocks, you use the carbon concentration, you know the depth of the soil, and the bulk density of the soil, which is the mass of soil for a given volume. Soil organic carbon stocks are often looked at in the 0 to 30 centimetre layer, as that's the international protocol. We've also looked at it here in the top 10 centimetres, as that's the zone that's most readily and quickly influenced by management interventions. There was a significant increase in soil organic carbon stocks on the ponded areas when compared with the runoff areas, which is really promising considering these interventions had only been in place for a couple of years. Katalpa Station, we see landscape scale changes occurring, increases in ground cover, shifts from annual to perennial systems, perennial grasses growing, which are really important for production as well as for increasing the carbon sequestration of soils. When we collect handfuls of soil, we can see, as in this image, life coming back into the soil, organic matter being decomposed, fungi actively growing and stabilizing soil structure, and these are really important components of landscape function. Our work collecting data at Katalpa Station has only just begun. We're driven to demonstrate the value of rehydrating the rangelands. The landscape changes that are being brought about are bringing function and life back to rangeland soils. They're bringing more cover, carbon, nutrient cycling and production to these systems. With that comes opportunities to diversify farm income, for example through carbon farming, and the creation of resilient landscapes.
About if you do and don't have healthy soil and life on your property. If you do have healthy soil, then you will have life and healthy grass. If you don't have healthy soil, then you won't have life and grass. And also you'll have terrible storms like dust storms.